For our final video for this unit, it's the idea of how we graph position versus time, how we actually show that changing in position as a function of time. So in simple terms, if you have an object and we're graphing the position on the y-axis and the time on the x-axis, that change in position divided by that time, the slope of that line is just going to be our speed, how fast it's going. The velocity will tell us whether it's positive or negative changes. Different graphs can show different, speeds depending on the slope. So on this graph, you can see 3 different speeds represented on the same graph for 3 different objects, but all going at different speeds. So in the same time interval, they travel to different distances. They have a greater displacement and a greater slope. Now, when an actual object is moving, very rarely does it move at a constant speed. So a lot of times we are kind of traveling between one point and the next, and you get a more complicated function. The average speed as it's moving through there is the difference between our final time, our kind of end point, and our beginning point. So it's, in this case, it's going from 2 seconds to 7 seconds, so a 5-second time interval. And the position changes from 2 meters to 10 meters. So that's going to be a path length of 8 meters. And so that gives you an average speed of 1.6 meters per second. But the instantaneous speed is changing. So if you look at this graph, the slope is constantly changing. For the first second, the slope is 0. And then it increases, reaches a maximum, and then kind of curves back down. So the slope or the speed is actually changing as we're moving forward. So what you can do, what concept you'll get in calculus especially, is the idea of what's called instantaneous speed. The instantaneous speed is the slope at a given point. So in this case, the slope is going to be kind of in between those values. It's not going to be equal to the average because each point is going to be different. So you have to be very careful with that. The instantaneous speed is whatever the slope is at that given point. Now we'll deal mostly with lines that are straight, lines, instead of curves, so you have to be more careful with such things. Then in calculus, you'll learn how to deal, whether that's this year, next year, or sometime in the future, or never, you'll learn how to deal with the slope of curves instead of the slope of lines.